Welcome to your AP Statistics lesson on sample surveys. We're going to talk about sampling techniques and also characteristics of a good survey. All right, just as a global concept, spending time to create good data is an investment. You cannot ever fix data collected from bad methods. Okay. You need to make sure you have a representative sample. You need to make sure you're asking the questions that will give you the answers you really want. So, first of all, big idea of examining a part of a whole. What we really want to know is information about a population. So, why not just get measurements or ask the positions of all members of the population? Well, a lot of times it's just impractical or impossible to do. So, we want to get a sample, a smaller group of individuals selected from the population. The tricky part is we want the measurements from that sample to reflect the measurements of the population. We want that sample to be representative of the population. Um, One example of sample surveys or opinion polls in political seasons, they happen a lot. And other times, a lot of marketing and consumer groups are interested in people's opinions about different services and goods. All right, so here's the thing, the sample must be representative of the population. If not, then you're going to be misled by what you find out. Okay, what you find as results will be true for that sample, but then when you try to take those results and apply them to the population, you're going to be disappointed because your sample did not represent the population well. Sampling methods that, by their nature, tend to over or under emphasize some characteristics of the population are said to be biased. So avoid it. There's no way to fix that. Okay, like I said, you have to have good data. Okay, idea number 2 is randomizing. Randomizing or randomization protects us from the influences of all the features of our population, even the ones we may not have thought about. Randomizing makes sure that on average, the sample looks like the rest of the population. Not only does randomization protect us from bias, it actually makes it possible for us to draw inferences about the population when we see only a sample. And so that's what we want to do. So we need to make sure we randomize. Okay, the third big idea is that it is the sample size that matters, not the size of the population. Not even the percentage of the population matters as far as sample size go, as long as it's not more than 10% of the population. Our methods just don't always work if it's larger than 10% of the population. Well, wouldn't it just be better to do the census thing? Well, let's unpack that a little bit more. First of all, it can be very difficult to complete a census. It's very hard to verify, make sure that you have um, gotten a response or measurement from every single member of a population. Populations rarely stand still. So there's people leaving or individuals leaving, individuals coming into the population. So it's very hard to be able to include everyone, um, which can take several days, but the everyone we're interested in can change over those days. So populations rarely stand still, and it is much more complex than sampling. With sampling, um, you have a much smaller group to tend to and to make sure you get measurements from. Taking a census is just really difficult. Okay, so what do we call that thing that we want to know about the population? Well, it's called a parameter. Okay, a population parameter is a characteristic about the population that we want to know. Okay, and we estimate those with sample statistics. And remember, the what we do to differentiate between the parameters and the statistics is that we use Greek letters for parameters and Latin letters for statistics. All right, let's talk about representative samples. Like we said, to be useful, statistics we compute must come from a representative sample. And the standard of by which all other sampling methods are measured is the good old simple random sample. It is such a it is the go-to technique to get started. Departing from that, you have to have a good reason to use one of the techniques we're going to talk about in a minute. Um, so, what does it mean to be a simple random sample? Well, first of all, there has to be an equal opportunity of selection for each individual. But you know what? That's true for some of the other techniques we're going to talk about too. What makes a simple random sample unique is that there is an equal opportunity of selection for each combination of people or combination of individuals as well. Um, s- and like I said, it's a standard against which we measure other sampling methods. So when we do the other sampling methods, there's always going to be like a, well, why are you need in your mind to go, why am I doing this instead of a simple random sample? There needs to be some reason why the alternative method is better. Okay, so how do we do a simple random sample? Well, first of all, you're going to need a list of the individuals in your population. So the population is the whole big group that we want to know about. Um, Sometimes we have a good list for that, sometimes we don't. Our best approximation of the list of all the individuals in the population is a sampling frame. Now, if we want to sample from the students at Houston Christian, we can get a sampling frame that has every member of the population. That's doable on any given day. We can do that. When it is something like the voters who are going to vote in the next election, and you're trying to get an estimate for that population of who they're going to vote for, well, the issue there is we don't know who's going to vote in the next election. So certainly we would limit it to registered voters, but then there's also likely voters that who are deemed to be like the voters who are deemed to be likely have patterns of behavior where they have voted in so many elections in the past. Um, the problem with that is you leave out all of the first time voters. So it's really hard to get the best sampling frame for the people who are going to vote in an upcoming election. That's why the predictions are off a lot of times. It's because they just don't have the right sampling frame. Then select your individuals. The easiest way to kind of describe or to conceptualize what's going on is what we call the hat method, but you can also generate random numbers. You can use, there's a table in the back of your book. We can also use the cast. We have lots of options. All right. So the other thing you need to be aware of, the results from one sample are going to be a little bit different from the next sample and going to be a little bit different than the next sample. If we choose different samples, there is going to be something called sampling variability. Okay, there's going to be a little bit of change from one sample to the next of whatever we're recording or measuring, and that's okay. We go into this knowing it. Whenever we formally make inferences about the population, we will take that into account with margins of error. All right. Suppose there are 80 students in an introductory statistics class and you need to select a simple random sample of 5. So here's the hat method. Write down each student's name on identical pieces of paper. Put them all in a hat and mix well. Okay, so the um, name on identical pieces of paper, and that helps with the idea that each person's going to have the same chance of their paper being drawn. Putting them in the hat and mixing well, there's your randomization. draw out 5 names without looking. That helps with the randomization. And then in this case, it would be without replacement because you need 5 separate individuals. If you made note of an individual and put them back into the hat, you could select them twice, and that doesn't make sense. Okay. One person can't take up 2 slots in a sample. If you did not want to do the hat method, you can assign each student a number 1 through 80 and use a table of random digits. There's one in the appendices in your book. All right, you have to take digits so many at a time. So since our largest value has 2 digits, we're going to take 2 digits at a time. That's why the student numbered 1 has to have a 0 in front of the 1. Okay, because we're going to be taking digits 2 at a time. If we had 100 students in the class or 300 students in the class, we would have to have 3 digits because the largest number that would be assigned to a student is a 3-digit number. All right, but we're doing 2-digit numbers. We're going to ignore 00 and anything from 81 to 99 because they don't represent a student. And we're going to ignore repeats. And we're going to keep selecting until 5 individuals have been selected. So let's use the digits provided in the example in your book. 0, 0, 5, 1, blah, blah, blah. So student 05, 16, 62. Ignore 93, that's out of the range. Ignore 05, that's a repeat. 77 and 48 will be chosen. Or you've got a third option. You can assign each student a number 1 through 80, and this time we don't have to worry about having the same number of digits, and use your cast to generate integers between 1 and 80. Don't do random number. It gives you like a weird decimal thing. You want random integer. You will still need to ignore repeats. So I have the steps there, scratch pad, menu. This is a probability thing. So probability, it has to do with randomness. So random, and we want integer. So integer. And then make sure you do 1 comma 80 and press enter and keep pressing enter until you have selected 5 different students. Okay, simple random sampling is great. It's not the only fair way to sample. In fact, sometimes there are cases where choosing another method seems more fair or fairer. Um, More complicated designs may save time or money, and it may help us, like I said, with equity. All statistical sampling designs, though, must use randomness at some level. If there's no randomness, then the data is likely not going to be representative. Okay, one way to modify simple random sampling is by using stratified random sampling. This is when the population is sliced into homogeneous groups called strata based on a critical characteristic. And by critical characteristic, that's going to be some characteristic that we think will affect the response. If we asked, uh, let's see, if we asked students at Houston Christian about whether or not we should get rid of prom, freshmen and sophomores may feel different about it than juniors and seniors. And so you would want to make sure that you have appropriate representation of the freshmen, the sophomores, the juniors, and the seniors. And then, so you would divide everybody up into their classification, and then you would take maybe 25 students from each class. All right, well, yeah. All right, so a simple random sample is conducted within each stratum and results are combined. All right, so one of the major benefits for this is you can actually see the differences in the different groups, but you can also reduce bias. You don't want to end up with a sample that is over representative of one group versus another. So to help you kind of visualize what strata are, here's a bunch of Skittles that somebody has sorted into colors. And so This is an example of the stratification of Skittles. They're all in different colors. So if we wanted to then end up with a good representative sample of all Skittles, we might take 20 from each of the different groups. Okay, another technique that involves splitting the group up into parts is cluster sampling. The difference is strata divide the individuals into groups where within the group they are similar, and then they are dissimilar across groups. They're not the same across groups. Blue and green are not the same. Clusters split the population into similar parts. So it's like the little bags of Skittles. Any one of those would be like a little baby random sample of all Skittles. Okay, so one group doesn't look that much different from the other. And then within the group, you've got everything going on. So the way this works is you just select one or a few clusters at random, and then you're going to perform a census within each one of them. Each cluster must be representative of the population to ensure an unbiased sample. The biggest benefit of this, it is much more practical than a simple random sample. Cluster sampling is not the same as stratified sampling, right? Because here we've got bags of Skittles all mixed together, and those are clusters. Here we've got little sections of Skittles that are separated by color for the strata. We stratify to ensure that our sample represents different groups in the population and sample randomly within each strata or stratum. They are internally homogeneous but differ from one another. Clusters are more or less alike. They are internally heterogeneous, and each one represents the overall population. We select clusters to make sampling more practical or affordable. Finally, there's multi-stage sampling. This is where you just combine several methods, and professionals do that very frequently so that they can get some of the benefit from each type of sampling. Systematic samples, that's where you're going to randomly select a starting point in a list um, or a group of people, and you're going to choose every eighth, say 10th, or it could be every fifth, every third individual to be in the sample. You have to fix that number. You have to know, okay, I'm going to select every eighth person. And then you randomly pick a starting point, and then from there, you just count off to 8, and the one that is assigned 8 gets put in your sample. Um, you want to do this only when you believe there's no order to the list that could somehow be associated with the responses. And a benefit of this again is it's more practical than a simple random sample. Okay, so let's look at an example. At Sumville High School, the administration wants to determine the student body's opinion about block scheduling. Determine the types of sampling being used in each of the following designs. One, we're going to select 5 out of 25 randomly assigned homeroom classes and conduct a census of each. Okay, so here we've got small groups where the individuals were randomly assigned. So each of the little groups could reflect the overall population. We're going to take a census within the group. So this is a cluster. So here's a cluster sample. Okay, we're going to obtain a list of freshmen, sophomores, juniors, and seniors. You're going to randomly select 50 students from each class, and then you're going to combine it to make your final example. So each of the groups that we're forming are like each other according to the variable within the group and different from each other when you look from group to group. And so these are strata. Notice that for a cluster, another thing that you can look at is that with a cluster, you take a census of the smaller groups, and for strata, you do a random sample from the smaller groups. Okay, we're going to obtain an alphabetized list of all the students. We're going to roll a die to determine a starting place. Choose the student corresponding to that number. So let's say it lands on 3, we pick the 3rd student, and then every 10th student from that point on. So you pick the 3rd one, and then the next person's 1, 2, 3, 4, 5. Once you get to 10, that person's in your sample also. That is systematic. The who of a survey can refer to different groups, and the resulting ambiguity can tell you a lot about the success of a study. So we want the who of our that we actually ask the questions of or take the measurements from to represent the whole population of interest. So we have the population, and then from that, our best estimate of the list of all the individuals is the sampling frame. And then we select the members of our sample. That's the target sample. People still have the right to say, no, I'm not going to participate. So people may self-select to not participate in it. And so then you have your actual sample. So the big question is, does this actual sample, once we get down here, retain the who of the population? Simple random sample is going to retain it. The others may or may not. As long as you're using randomness, you have a pretty good um, reasonable expectation that representativeness is attained. But SRS is the one that we really rely on. Okay, so now that you have the individuals that you want information from, the survey itself must be valid. In other words, it must give the information we are seeking about the population we are interested in. So, the very first thing you have to do when you're creating a survey is know what you want to know. What exact questions do you want answered? Um, then you want to use the right sampling frame. You want this, again, this is another reason why statistics is important for people in all kinds of fields, because this may require field specific knowledge to know what would be the best sampling frame. And then you want to tune your instrument. Okay, you know what you want to know. Um, you really don't want to ask more questions than you need to ask, because the longer the survey takes, the fewer people that are actually going to finish it. You want to ask specific rather than general questions. You want to ask for quantitative results whenever possible. Be careful in phrasing questions, and be careful in phrasing answers if it's like a multiple choice type of question. You can actually bias what people are going to select or say just by the wording of the question. So you have to be very careful. The best way to protect a survey from unanticipated measurement errors is to perform a pilot survey, a trial run of a survey you eventually plan to give to a larger group. When you are the person who writes the survey, you may think the questions are absolutely crystal clear with no way of being misinterpreted. But when you conduct a pilot study, you may find that readers don't feel the same way. Okay, so let's talk about how to sample badly. Um, First way you can sample badly is with volunteers, and this is done all the time. In a voluntary response sample, a large group of individuals is invited to respond, and all who do respond are counted. Okay, there's no like going through and picking anybody. There's no use of randomization. Every single internet um, type of survey that you see where you know asking you for your participation, that is voluntary response. Um, these are going to be biased, especially to those who have strong opinions. If you're kind of meh about an issue, you're not going to waste your time answering questions about it. But if it's something that, especially negative, that like really irritates you a lot, you might be um, more inclined to be able to express those opinions. The results are useless for inference. So it's great that people do that, but you're not going to be able to apply your results to a larger population. Another way is to sample badly but conveniently. Okay, so a convenient sample is is simply what it says. You include individuals who are convenient, and they may not be representative of the population. So that would be where the researcher is still selecting them, but they just select whoever is convenient. Maybe they ask members of their family. Maybe they ask, if I wanted to know the opinion of all high school students in the U.S. about prom, whether we should continue to have proms. Well, and then I just interviewed kids, I just included kids from Houston Christian in my survey. I'm probably not going to get a representative answer to the entire whether the entire population of high school students in the U.S. want to get rid of prom. Another thing you can do that's not going to be very helpful is to sample from a bad sampling frame. You can conduct the best simple random sample from an incomplete sampling frame, and it's still going to produce bias. Um, the reason for that is the individuals who weren't included may differ from the ones not in the frame. This leads to undercoverage of the groups left out of the sampling frame. So earlier when I talked about using likely voters to measure who's going to vote for who in an election, the problem with that is that new voters are underrepresented. Okay, so um, that's going to affect the results because you're going to undercount the response, the tendency of new voters, and especially if they are systematically for one candidate more than the other, you're not going to get an accurate result. Okay, more stuff can go wrong. Um, if the people who refuse to answer your survey have opinions or measurements that are in common that differ from everyone, from those who are willing to respond, then you can have what's called non-response bias. Okay, where you're not leaving them out, like with the sampling frame problem, but they're refusing to answer, and so you're not going to get information from people similar to those who are refusing to answer. Do not bore respondents with surveys that are too long. Surveys that are too long are more likely to be refused, reducing the response rate and biasing all the results. Or people just get bored and they just start picking like a middle of the road, generic kind of answer so they don't have to think about it. You want to work hard to avoid influencing responses. Response bias refers to anything in a survey design that influences the responses. If the dean were to do face-to-face surveys about academic integrity, you would get a very biased view of academic integrity um, incidents at Houston Christian. Students are not gonna fess up to having issues with academic integrity when it's the person who can punish them for it asking the questions. Another thing is the wording of a question can greatly influence the responses. Um, Suppose I want to ask people about their opinion on supersized sodas. If I phrase my questions like this: sugary drinks contain hundreds of empty calories. Obesity runs rampant in the United States. Should people be allowed to buy supersized sodas? Well, that's going to prime people to say no. And that's not going to give you good results of people's actual opinions about whether or not they should be able to buy, ginormous soft drinks. So you want to look for biases in any survey you encounter before you collect the data. There's no way to recover from a biased sample of a survey that asks biased questions. Spend your time and resources reducing biases. That's incredibly important. The best way you can do that is with a pilot test of your survey. You always want to report your sampling methods in detail, um, so people can look at that in case there are some biases there and they can see where they come from. All right, guys, that's it. Do the problems to try on your own, and I will see you in class. Have a great day.